Okay, good morning everyone. Welcome to the last week of the course. First of all, I would like to apologize. We just noticed that the tutorial from week 3 was apparently missing from the website. It was uploaded. For some reason it's not showing, but anyway, it's been on the course's YouTube channel, so maybe some of you have seen it anyway, but I will fix it as soon as this lecture ends today. But apologies for that. We will probably extend the deadline for week 3 anyway because of that, and there have been some requests from some of you. But yeah, so today we are going to talk about a bunch of things. We have covered a wide range of theoretical things, practical things related to cartography, and we noticed that we have left a few loose ends here and there. So today's lecture might feel like we're jumping from topic to topic, and that's because of what I just said, that they have left things that we haven't really opened up. So today we cover those things. We also have a bunch of practical things that we will go through, so very specifically related to what tools to use and stuff. And toward the end of the lecture, we will have also a discussion about the trends in cartography. Like every other field of science, things have been changing rapidly lately. We have AI, we have other tools that are emerging and getting more and more popular. So we will have a couple of slides going through some of the things that already exist, and we will have a discussion around the topic. And as I already announced on Discord, today's guest speaker is Tuuli Toivonen. So she will join us around 10:30. So hopefully we will cover most of the lecture materials before then, and then we will have some few minutes of break, and then Tuuli will continue for maybe around half an hour, and then we will continue with our discussion. Yeah, so these are the topics that we will be covering today. We have been talking about the storytelling, but we haven't really opened it up, so we will have a couple of more slides today about it, especially because we will be hopefully using them in our final portfolios, final project of the course. Then very briefly going through the non-cartographic visualization, which we already talked about in the tutorials. Then map design, a few things that we haven't talked about yet, specifically about designing and producing static maps and interactive maps, which is interactive maps are the main focus this week. And for those of you who have checked the tutorial already for this week, you know that this week we are working with interactive maps. So we will cover it during the lecture as well. Then we will look at the cartographer's inventory. So we will look at some of the tools. This is the question that very often comes from people who want to make maps, that what tools should I use? We have practiced some of these tools during this course, during the past 4 weeks, but we will see what other things are out there that we can explore. Then one thing we have used already a lot, but we haven't talked about is data classification. So we very quickly look at data classification and what it means for cartography. And then, as I said, we will talk about AI and some other trends in cartography. At the very end, probably after the break and Tuuli's talk, we will talk for a few minutes about the final project and what we're supposed to do. So storytelling about maps, storytelling with maps. So as I mentioned last year when we were teaching this course, we had a guest lecture from Salzburg, Franz Mochnik. So he gave a whole lecture about the storytelling with maps, and his approach to map making was very interesting. Now we have he didn't let us record him or publish the materials. That's why the talk is missing from the course's website, but we have a summary of it there on week 3, so you can check it out. But his approach to map making was quite interesting, very personal. And the idea was that, well, he's not the only one working in this field, but the idea is that through maps, you can tell a narrative and make it a bit personal in different ways. And through that, you can make the map a bit more influential. So why maps matter for storytelling? There is emotion in data. Numbers alone are a bit abstract. Well, sometimes if there is a simple number, it can come with some emotion alone. For example, when we had the pandemic, they were publishing numbers, and the number alone about, I don't know, the number of people who were getting infected or dying from the disease, it already carried some emotional weight. But very often weights can be accentuated through visualization. And map is one of the form of visualizations that we talk about here. Beyond text, unlike linear text, maps offer multidimensional narratives. So when you have text, of course, that's one form of saying narratives, but through map, you have different dimensions. So as we will talk today, in your map, you can have different elements. You have text, you have visualization, you can have other multimedia that we will cover today. And through that multidimensional approach, you can take a new approach to this storytelling. So that can become very effective. And cognitive engagement, spatial visualization taps into different ways of understanding, as we have talked a bit throughout this course. So you probably, like, the pandemic wasn't that long ago, so most of us probably remember how it was. Very often that we had this, like, that was one of the occasions where we were seeing a lot of like different kinds of visualization, maps, charts, and different infographics about how the pandemic is spreading and what are the statistics about different things. So, and you see that you probably remember that there was a lot of like discussion and controversy around many statistics that were published, many visualizations. Like, you probably remember the visualization can affect how you feel. There were times that you see a chart, you see a map, and say, oh, okay, there's hope that this pandemic is ending finally. And there were sometimes like just, you look at a visualization and say, oh, wow, that looks bad. So these are the things you can do with visualization. That's why we talk about it on the next slide, that it's important to be like, there are ethical things to take into account when creating maps. So there's a classic book that many of you, I'm sure, are familiar with, How to Lie with Maps. There's an old book from a few decades ago, but recently there has been a new version of it. They have just, I guess, made the maps colorful and made some improvements. But that's a good example of seeing how you can tell different stories basically with the same data, using different, making different visualization decisions. So some ethics and best practices in map-based storytelling, some ethical considerations. So descriptive versus perspective. So maps can influence behavior. So this is something we talked about already a couple of times, that with maps you can affect things. So they have political influence, they can influence people's behavior. For instance, now there is this discussion going around in urban domain that people's choice of routes has changed drastically in cities, because most people are using navigators. So you used to just take the main road from when you were traveling from west of Helsinki to east of Helsinki, you probably would have taken just main roads. But now the navigator might just tell you to go through some smaller streets and alleys. So these maps are changing how people are actually behaving. False causality. So this is another thing that it's a misunderstanding that you can easily cause in your visualization, whether it's a map or other form of visualization. You might mislead people by making them think that there is some causality in what you're showing. A classic example of this is the correlation between number of drownings and ice cream consumption. So if you make a map or a chart showing how much ice cream is sold in the shops per week, per month, and you also make a map of how many people are drowning in the open seas, then you will probably see a correlation, because I don't know the statistics, but I can imagine that people eat more ice cream during summer, but also that's the time that many people drown, because people use the sea, go swimming, and so on. So you might think that there's a correlation, and if you do a statistical test, you probably see they're correlated, but there is no causality here. So this is a classic example of how you can lie with a map or with your visualization. Performative power, maps can create perceived realities. So there's a classic case of map trap. Has anyone heard of that? Map trap is a real story. So maps can create reality, something that doesn't exist. If you just put it in your map, it might become real. And the classic story of it is the map trap case. So in early 20th century, I guess 1920s, 30s, there was a company in the United States making maps. So their job was, they were cartographers, they were just producing maps. And making maps back then was different. There was no computer, no So this was like, there were a few companies that were mass producing maps. So they were worried that people would copy their maps. So you have gathered data, you have produced your map, and someone else might just copy it and print it somewhere else. So what they did back then was they put traps in the map. So they put random words or name of places that did not actually exist. So if someone copies the map, they would be like busted. So you don't even say, okay, this place doesn't actually exist. It's just a trap we had put so that no one copies our map. So what they do, they create a random place that doesn't exist. They mark it on the map somewhere north New York. And I guess it was something like Agloe or something like that. The place didn't exist. It was just a random dot with the name Agloe somewhere north New York. And they published the map. So what happened, many people started copying the map. So that place actually became real. So people started referring to that area as Agloe. And even a store appeared there, and they named the shop Agloe. So even if this was like 8 years ago, I checked this yesterday, and if you search on Google Maps, the name of the place is still Agloe, and there's a shop there with that name. So this was a random place, just a trap for copyright reasons, but it became real. So that's a very simple example of how we can create or alter reality using maps. So you should be careful with that. So some good practices when it comes to creating maps. Add personal context. This is not something you can always do because it depends on what you are visualizing. If it's your job to produce a map, if you have been given a data to make a map from that you have no personal connection with, this can be a bit challenging. But in some cases, if you are a researcher, if you are somehow more connected to the topic, creating that personal connection is a bit easier. This is something you can already practice during this course when you're doing your final portfolio. We have some, if you have checked the material, you see that we have provided some examples of what data you can use for your work, but you have pretty much a lot of freedom what data to use for making the map. But there you can try to choose a data set that you have like some connection with, something that is important to you or you can relate to. Then you can add that personal context to how you visualize the data. And probably it can be easier for others to relate to your visualization if there is that personal touch to it. Then embrace minimalism. So we have been talking about this a lot in different contexts, so don't make your map overly crowded. This also applies to the story you're telling. So if you have a certain focus, if there's a certain aspect of data you want to explore and visualize, then try to stay focused. So don't distract the reader, the viewer too much. So try to embrace minimalism and iterate thoughtfully. So this is again something we have talked about. It applies here too. If you make a story, if you make a visualization, start with a sketch and see how you're conveying that story, that message, that information from your data, and then go through this iterative process to improve your visualization. So there's a bit more about that place, and yeah, the name I remembered correctly is Agloe. So yeah, so non-cartographic visualization of geospatial data, and today Tuuli has one good example of this when she will join us later. But we have talked about this partly at some points, that it is when it comes to geospatial data, and this is again we are wrapping up things so that you would use them actually in your portfolio. When you're working with the data, think a bit out of box. So yeah, this is a cartography course, so you're expected to produce maps, but at the same time you might be able to explore different dimensions of your data through different kinds of forms of visualization. So you might want to include charts and graphs. We are familiar with this kind of infographics, which you can see different things. So there is some map, it's not the main focus here, but there are charts, there are pictures, there's a table. So if it supports understanding, if it supports you in telling the story you want to tell, then you should try to use them. So when you're making your map, you can benefit from a wide range of media to tell your story. So of course the main thing, the main focus of our course here is creating the maps. But remember that at the same time there are other forms of visualization, some of which we have looked at, charts are a simple example that we are familiar with. At the same time, try to couple your maps and visualizations with text and narratives. We had a good example of this in week 2 when Marco Kallio was visiting us. He had this long map of a river in Asia, and he had put text at the same time. So we had a combination of text and nice visualization to tell a story about the river and how it is connected with people's life in that area. So consider doing that. And then images, very often you have seen these maps that have images at the same time. So this can be just image next to your map if it's a static map. In case of interactive maps, we see an example of this in our tutorial this week. There might be a pop-up, you just click, you see something, some image. Or other forms of multimedia. I have seen like maps of birds. I guess it was an example from Finland, that there was like different kinds of multimedia there. So you see where the habitat of a certain bird is, and then when you click on the habitat, you can see images of the bird. There might be audio files. You can also hear what the bird sounds like. So this is something that is very relevant, for example, to a bird map. So you can include different kinds of multimedia. But one of the things that we are going to talk about today, and it's very practical, is about producing maps. So we have learned a few things about how to make better maps, but you want to actually, when you're out there working, you want to publish that map. And now we are going to talk a bit about how you publish your map. And there are different ways. And what are the implications of your medium of choice in your cartographic choices. So if you decide to print the map on paper, or if you decide to go with an interactive web map, then how should you reflect that cartographically in your design? So that is something we're going to talk about. But generally speaking, well, we always start with data. It can be raw data, or sometimes it's pre-processed. Then you work with the data. You usually need to do a bit of preparation, and then you get to a presentable form of data after cleaning and some processing. But sometimes this leads immediately to a map. So you have a data set of where the birds are, and you want to just export this as a dot map. So this doesn't take so much analysis. You just want to, you have the data, you put it on the map, maybe you add a base map, you export it. So that's one way to go. So you have the data, you just go to exporting. Sometimes you have to do some kind of analysis, and then you go to the map exporting part. So you go through GIS. So whether you go whether you do analysis or not, you usually go through a graphic software before making the final product. And that graphic software can be like the layout view of QGIS. So, QGIS as a GIS is the part where you had the layers, you have the tools and everything. You can do the GIS part. But then you have this layout view, which is not really a core part of GIS. It's more like an integrated graphic designer. So instead of taking your map to Photoshop or some other software in QGIS, you have this layout designer that allows you to put a legend, drag things, copy things, put a photo, add text. So you go through that graphic software. Like I said, if QGIS or whatever software you're using is enough for you, then that's it. Already in this course, we have a few people who are using, for example, Photoshop to make their map a bit nicer, or other software. Last year, we had some students who did that. And of course, if you're comfortable with those programs, then definitely you can make your map look much nicer if it goes through Photoshop or something like that compared to just QGIS. So that's something to consider. So a graphic software. In case we are using Python or programming, then that graphic software, of course, you can always combine. You produce your map to some extent in Python or other programming languages, then you take it to a graphic software, or if you're very comfortable with image editing, there are a lot of libraries, for example, in Python for editing images. So you can have that graphic interface in Python without the interface, but you can do graphic processing. Then another path the data can take is through geoservices, and we are familiar with WMS and WFS, where we have the possibility to publish vector data and raster data. And this is one of the ways many organizations that work with geospatial data share their data with others. So that's another interface of the data. And that can be shown as something static or interactive with multimedia and so on. But yeah, so today we are focusing on we are not working with geoservices on this course, but we will be working with maps, like simple maps, static or interactive. And before we continue, let's look at a few examples, if I can show them here. Drag this here. So when I talk about the story maps, like you can search and there are many good examples. I just found a few. So this is an example of a story map. Like ArcGIS, the Esri has been super active in this. So when you do search, you will get a lot of story maps that are made with ArcGIS product, which is I guess also called a story map or something like that. But you can make this in many different ways. So you have probably seen this kind of visualizations that you can just scroll through a website and you can get a combination of things. So it can be different kinds of multimedia, video, images, statistics, tables, and so on. So this one has a lot of visual details. There are simpler examples, maybe something that you can aim for in your final portfolio that we will talk about later. Like this. This doesn't have all those like cool visual effects, but it is following the same idea that you have a story to tell. You're talking about something. You have some data you're working with. You start telling your story, and then you back your story and your observations with visualization, and you explore different visual forms to tell your story. So we will get back to the topic of your final project, but this is what we had in mind when we designed this final assignment for the course. Yeah, so if you do a bit of search, you will see many examples of this around the internet. So map making process, we have seen different versions of this in the last week, so I won't go through details, but yeah, so we have some data we want to work with. We have some objectives. We have done our work with data. Either you have collected your data or you have taken it from somewhere, you do some processing. Then that's where we get to the point where we want to create the map, which is the interesting part for this course. And yeah, so we have talked about creating the map image a lot during the last few weeks. And today, now, in the next few slides, we are going to talk about this step, which is adapting the map to the medium. So whether you're printing it or making an interactive map or a digital static map, you should make some choices. So this is where we are now. And then the last part is the final product distribution and dissemination that we will touch upon a bit later today. But the static maps are fixed representations of spatial data, meaning they do not change or allow interaction once they are created. They are typically produced, well, they used to be produced mainly as like printed form, but nowadays we also have image files that are static. So these are the most common types of maps we have made. So these are very familiar. There are a few considerations. Like one thing that is important about the static map, and it makes it a bit like, it makes it a bit more like sensitive task when it comes to creating static maps, is that it is a static. Once you make the map, you cannot change it. The viewer cannot do anything about it. So if it's a good map, then great. It's very useful, very usable. But if it's not, the user cannot do anything. Because with interactive map, the person has the possibility of interacting with the map. So if the visualization is not good, if the zoom level is not good, if you have not chosen the extent of the map properly, well, that's bad, but still there is a chance that your map can be usable because the person can interact with the map. But with static map, if you have done it poorly, if your zoom level is not good, if the extents are poorly chosen, then you can't do anything. So that's why you have to do a better job making some choices. So when it comes to maps, static maps, you should take a few considerations into account. How will it be viewed? So is it going to be digital or printed? If it's printed, will it be with a large plotter, or are you going to use just some simple office printer? What kind of paper you're using? And then it comes to whether you want to print it or publish it as an image. Then the one question you have to answer, or one decision you have to make, is the format, because you probably have seen many times, like when you're exporting a map from QGIS or in Python or any other environment you're using, you have options. So very often we don't think about it, we just export it as JPEG or whatever image file that is the default, but that is something that we are going to talk about today. So when it comes to printing, so now let's start with printing. So one thing that is important is the DPI, or dot per inch ratio. And this is a source of confusion for many. When you're exporting your map from, again, QGIS, Python, doesn't matter. When you're exporting your map, one option that you can provide or adjust is the DPI. And DPI is for printing. So if you are not printing the image, like on paper, DPI is irrelevant for you. So it makes the file very heavy, so it exponentially gets heavier. So if you choose a very high DPI, the file gets heavy and the process of exporting gets very long. But if you're not going to print it as on paper, then DPI is irrelevant for you, so you don't need to think about it. So we have the DPI, and then we have resolution, which is the dimensions of your map or your image file in pixels. So this is something that is relevant to both printing and digital images. So if you want to export your map and print it on a paper, you should think that, okay, I want high resolution, so export your map in high resolution, but at the same time you should be careful that the map has high DPI and for printing. But if it is just for computer, then resolution is what you think about. So what DPI should you go with? Depends on the printing device. Of course, if you have a home, this like the simple printers at home, then there is a limit what DPI do they support. So you don't need to go very high with the DPI. But if you are sending it to some professional printing service where they are using some advanced plotter, then they can support higher DPIs. So it depends on the printing device and its capabilities. So an Office inkjet prints up to 600 DPI. No need to export any higher than this because it just takes space and makes the exporting process a bit longer. But usually for printed materials, 300 is the average. So then it comes to the exporting. So this is something we always do. Once we are done with the map, we want to export it. So with the static maps, very often we export our maps as image files. But when we are exporting our maps as image file, we have to be careful and know a little bit about these file formats. So we are very used to seeing images coming as JPEG files or PNG files that we may not think. You just export it because it's there as default value. But you should think how this works. Well, PNGs and JPEG files are both like compression-based formats. So when you're exporting your image as a JPEG, then it is compressed. And the algorithms behind the compression are different. So when you're exporting your map or any other image as a JPEG, you are essentially losing quality. So the algorithms works based on simplification of things. So when you export your map as a JPEG file, what you might see if you really zoom in into details, you will see that some colors are a bit distorted, some things might move. So the colors might leak into the neighbor pixel. So these things can happen. So if you are really making a precision map, which is often the case with maps, we want to be precise. It's like different than your photos, like personal photos. So you want to have that level of precision. So generally, JPEG is not recommended. Of course, it's a bit lighter file if you have problem with the storage. If you have a website and you want the precision is not super important for you, you just want the website to load quickly, then JPEG can be a good solution for you. A good file format, but generally it's not recommended because you lose details. But if you still want to go with compression, if you want to make the file smaller for whatever reason, then there are other formats such as PNG, which are lossless. So the algorithm behind PNG is not based on losing the quality of the data. It's more about how the data is stored in a digital format. So it's more compact in that way. So the compression is lossless. So you can go with PNG. The file gets smaller, but still the quality will not get worse. So these are the things. So there are other file formats for images that, but if you choose to go with them for whatever reason, then do your research and see how that works. So there's a bit of complexity behind file formats. Yeah, but generally speaking, these images, they reduce the size. They're easy to work with if you want to just put it on a website, on a Word file, in your PDF, or I know PowerPoint. You can just put them easily, so that's why they're super common. But sometimes you want to avoid compression for a number of reasons. For example, you want to print it on later, or you don't have problem with the storage. It doesn't matter to you if the file is, I don't know, a few hundreds of megabytes. Then you might go with without compression. Then there are file formats for that. So if you export your map as a BMP file, bitmap file, or a TIFF file, TIFF is a format that we get the raster files in usually. It's not compressed, so you're getting the image in its original format. So if size is not a problem for you, if you don't want to put it on a website, then why even do the compression? So these are some of the things to take into consideration. There are other file formats that you may consider using, depending, again, on what you're doing and how you want to share your map with others. PDF is a good balance between file size and image quality. So there is compression happening, but at the same time, the quality, again, depends on the settings when you're exporting, but the quality can be preserved to a good extent. And it's suitable for many users. Again, if you remember when we had Marco Collier here 2 weeks ago, well, he had a printed map here, but the format in which he shared the map was PDF. And I remember we had a discussion about how long a single PDF page can be. He had a bit of problem with that. But like in his case, PDF was working nicely because it was a very big map. So probably the size of file was a problem for him. I remember when I was like downloading the file, it was quite large. So even with PDF, it was still a large file. And the other thing that was that he had this unusual shape of map. It was a rebar. It was a very long shape. It was very long. So PDF was working nicely in his case. He had these limitations, but it worked nicely enough. So PDF might be one format. And it's, PDF is very easy to share with others. And then we have vector formats. There's EPS, there's SVG. And we are familiar with the benefits of vector over raster, so we won't go there. But one good reason we may want to use vector formats is high resolution. So for printing reasons, vector is good. And if you want to, many graphic programs work nicely with vector format. So if you want to take your map later on to a graphic software to work further on it, then vector is a good choice for you. In software, in ArcGIS, in QGIS, other software, it's easy how we export in different formats. You have this interface. You can choose what format, what is the compression level. So that's very easy. And for those of you who use Python, when, for example, with Matplotlib, when you're exporting the map, you can choose what format you want. Do you want PNG or JPEG? And in case of JPEG, you can specify quality, which determines the level of compression. So the lower value would mean that you will have higher compression, we would lose more quality. And then DPI is an optional parameter you can pass to the function, and that will determine the DPI for your map. So if you want to print it, remember to provide a value for DPI, otherwise it probably would go with some default value. So jumping to another topic that we have, it has been mentioned during the course, but we haven't really opened it up. Now a bit more detail on it, and that's fonts in cartography. In the first week when we had Mikael Asikainen presenting his work to us, he mentioned the topic of fonts, and he said how important it is. For those of you who followed that lecture, you remember that he worked with different kinds of maps. He had made many maps for like novels, like fictions, and depending on what kind of genre of book it is or what kind of map he wanted to make, he had used a wide range of fonts. So it is relevant to any kind of map. Of course, when you're choosing the map, one advice we got from him was that do not go with the default because, well, depends on what the default is, but explore a bit, think about the font you want to use in your map. So fonts are very important, and it's not limited to maps. Sometimes you get a text that is in some annoying font and you hate reading it because it's just uncomfortable to read or annoying in some way. And it just affects how the text looks like. So it might be a very nice report or a map, but just because they have used a terrible font, then you may not like it. So be careful with choosing fonts. Again, it comes a lot to what is available to you on your computer, what fonts are installed, and also what is the context, what is your preference. But sometimes we don't know how to choose. So if you look at cartography books, there are some guidelines. So you have no clue what to do. If you have no preference, then look at some of this is from one of the references of the book, the course. I don't remember which one, but it's at the end of the slides. But yeah, some suggestions. So generally speaking, we have two families of fonts. So we have the serif fonts and we have the sans serif fonts. So serif means small lines. So they have small lines at the end of the characters. Examples of these that we see a lot are the Times New Roman, we have the Garamond. And generally speaking, these fonts are recommended for printed materials. So if you're going to print your map and you have no idea, you have no preference what font to use, this can be a guideline for you. So going with serif fonts for printed material. So some examples according to cartography books that are more common among maps and recommended are listed here. So we have the Baskerville, they have Bodoni, Bookman, Old Style, Times New Roman. So a few things to choose from based on your preference and what looks nice according to your style and map. Then we have sans serif fonts, which again, this is not absolute, but if you have no idea what to do, these are usually recommended for digital media. So if you're sharing your map, for example, on a website or digitally with someone. So as you can tell from the name, they don't have serifs. Examples of that are the Arial and Helvetica. And there are some common examples for mapping. So Arial is usually the default for most software. And then we have also Century Gothic and Comic. Now, Comic is people have this complicated relationship with the Comic font. Some people think it's very nice and comfortable and accessible. Some people just think it's overused. So it's a matter of taste also what you choose from. But these are some recommendations according to cartography books. Then when it comes to fonts, choosing fonts is one thing. The other thing you have to choose is the size of it. And for deciding about the size of the text, well, first of all, it comes to visual hierarchy that we talked about in the second week. So how much do you want to emphasize that text? So if it is the headline of your map, and it's very important, you want everyone to see that headline right away, then of course you go with a bigger font size. But if it is not super important, for example, you have used a base map from OpenStreetMap, probably you don't want it to be the first, and you want to give credit to OpenStreetMap. But probably you don't want it to be the first thing that people see when they look at your map, that this base map is from OSM. So then the size, of course, gets smaller. So that's one thing, the main thing, visual hierarchy. Another thing is the viewing distance. So if you're printing your map, this is particularly important if you're printing the map. If you're going to a conference or you're just showing a poster somewhere for some reason, then you should be a bit familiar with the setup. So if it is is it a poster that people can get really close to look at your map, or are they going to be a few meters away from it? Or if it is digital, is it going to be on someone's laptop where they can just get close to the screen and look at it? Or is it going to be shown on a big screen somewhere in a conference hall or I don't know, whatever venue you're showing your visualization in? So these affect how what sizes of fonts you want to use. Again, this is from cartography books, some recommendations. So if you have no idea what works best for you, these are some numbers to go with. So for example, here for the layout titles, whether you're using the Times New Roman or the Arial font, there are some consideration depending on viewing distance. So if you know the person is going to look at the map from a very close distance, then going with a font 22 to 28 is probably enough. But then again, if you're going to put your map somewhere very far and the viewers are looking at it from 6 meters, 7 meters distance, then usually go with over 100 font size. So yeah, so again, if you don't have any idea how to choose this, there are some guidelines out there. This is just one example, and you can check those out. Now, of course, for body text, the text that is not your headline, you go with a smaller font. Yeah, so these are not like the super exciting topics, but these are important things that we have to decide about when we are exporting our maps. So another thing that came up, was it last week, animated maps, and we are working with them, not really, well, we are working with them in this week in the tutorial that we have published already yesterday, is the animated maps. So now we divided our maps into two families of, like two categories of static maps and interactive maps. We talked about the static maps already, and we are going to continue with interactive maps. But animated maps are kind of in between. That's why I have a couple of slides about them before we continue to interactive maps. The interactive map, the animated map that we make in our tutorial this week is more on the interactive side. For those of you, has anyone checked the tutorial for this week yet? Not yet, but when you look at it, you will see that we have an animated map that is made in Plotly in Python. There's a similar QGIS version as well. But yeah, so there's a slider. We have the temporal dimension in our data. And there's a play button. There's a slider, so you can just browse through your data temporally. And you can see it's fire incidents from Finland from, I don't know, 2010 to 2020. So we show that temporality with a slider, and there's a play button so you can see the animation. So it's a bit interactive, but very often you see these kind of maps that are not interactive, they're just animated. They are very often published as like GIF files. So these are between like a static and interactive kind of, but they're more on the static side. So what it is actually is just a number of images that are being played in a sequence. So in the tutorial we mentioned that I couldn't find any, maybe I didn't search hard enough, but I didn't quickly find any library that would make you an animated map in Python. There might be if you search better, but if I was to make an animated map like this, I would just make a number of static maps. So I would, if I go with the fire incidents in Finland, I would just export maps for each year, if that's what I want to visualize. And then there are many libraries to convert your single images into a GIF file. So it's basically a number of static files that are being played in a sequence. Then you get the animated maps. Of course, there are probably software and many cool tools to make this in different way, but that's how you would make it in a simple way, at least. Yeah, and they're ideal for showing extra dimensions, very often temporality. So if some phenomenon is changing over time, for example, that's actually from the fire incident data. So if it's something that is changing over time, then this kind of animations are useful to show how it is changing over time. Yeah, we go through the details and techniques and example in the tutorial, so you will see that later on when you're checking those. Then continuing with the interactive maps. Do you have any questions until here? We're going a bit fast to cover most things before Tuuli comes. If not, we can continue with interactive maps. Again, I won't go through details of how to do things because that's something we cover in the practical side of the course, but just covering the theories here. But we know what interactive maps are. They are digital maps that allow users to engage with the data in different ways. Like many of you have taken the AutoGIS courses where we create interactive maps using Folium library, and there you know that what we did there is just, okay, you can add a tooltip, you can have a pop-up to the map. One thing we didn't do, but it's easy to do with Folium, is to add also like layer selection. So you might turn on, turn off some layers. This is something we do all the time when you're using Google Maps or other online map services. So these are different kinds of interactions you can have with the map: zooming, panning, clicking, and querying, and different kinds of interactions. So we have talked about map elements in the first week. And I guess we already then mentioned that map elements, but we have a bunch of map elements that are universal regardless of what kind of map you're making. For example, a scale bar is useful whether you're using an interactive online map or a static map you have printed. But there are some elements that are unique to interactive maps. For example, we have the zoom control. In an interactive map, you have layer toggle sometimes if you need it to enable users to turn off, turn on certain layers. You might have a search bar in your map. That's often the case with online map platforms. You might have pop-ups, you might have tooltips, but there are a number of elements that are unique to interactive maps. Yeah, so many things that we have covered. So there are those specific interactive parts of the map that you should be careful about. So they are usable, they're useful, and also there are design methods that are a bit the same. So when we talk about using map elements, when you're talking about visual hierarchy or using colors, it doesn't make so much difference if it's an interactive map or a static map. So those things also apply here when you are creating your interactive map for this exercise this week, or later on for your work. So remember that those are not just for static maps. You should apply the same logic there. Another thing that is important and specific to interactive maps is the zoom level. So zoom level, of course, is an interactive map. If you get it wrong, it's good to know that still the user can adjust it, but it's good to get it right to guide the user to the area where you want to present your data from. So in the examples we have this week in the tutorial, we are working with fire incidence data from Finland, but we are using interactive maps that are global maps. So in our choice of extent and zoom, I've tried to be careful so that the map starts with Finland. So because that's where our data is from, not to distract the user. So you should be careful with the zoom level, the initial zoom level. Zoom levels are usually between 0 to 20, and this doesn't come in any specific unit. It's something that web platforms have come up with and has become a standard. So you should go with trial and error, see which one works better for your case. So a number closer to 0 is more like on the world view. It's really zoomed out. Then you go to closer to 20, you will get the street view, very zoomed in. And depending on what you're showing and what is the scale of your data, you should go with something that is suitable. Then there is the topic of projection. This is, it depends on what you're using. If you're just using some Google Map-based service, then you're really limited by the projection they provide. Very often you don't even have the possibility of changing that. So if you can't change it, then just be aware of what projection is coming in and what are the strengths and limitations of it. Like for example, OSM, Google Street Map, they're using WebMercator. You just need to know that be familiar with how WebMercator works in different longitudes, in different latitudes, and just be familiar with that. For example, we know that WebMercator is not really a Mercator, it's just dynamic. So if you zoom in different places, it works differently. So not the same exact projection is applied in Finland area compared to equator. So just know what you're dealing with. And if you have the possibility of adjusting that projection, if that service you're using allows you to do that, then use what you have learned about projections and use something that is suitable for your study area. Another thing that is important when it comes to interactive maps is optimization and performance, because that's something you don't think about when you make a static maps. But if you make an interactive map that is super heavy and it might crash the browser, then you should just do it differently. Use a different library if you're doing it with Python, or simplify your data, or just limit the number of data sets that you are including in your visualization. This is something for those of you who do the Python version of this week's tutorial. This is something you will notice. So I had to make, because we are using Jupyter Notebook, and when we had all the interactive maps in one single notebook, it was just crashing. It was too heavy. So what I did, I divided it into 2 files, and I had to make some decisions to make it a bit lighter. So this is something that you should live with. There are some technical limitations, performance limitations, to keep the map useful and usable. So very often we get the question, okay, what tools and technologies should I use if I'm making interactive maps? Well, the best way to go, as you can guess, is the coding, the programming way, because there's a lot of programming behind it. Even if you're not coding yourself, when you have an interactive map, it's just running on JavaScript and CSS and a lot of these things. So if you're not comfortable with that, if you want to really avoid programming, you can still use some software platforms that allow you to create interactive maps. So for example, ArcGIS Online allows you to do that. Google Maps API allows you to make some simple visualizations. There's Mapbucket Studio. And in QGIS, I guess we see one of these in the tutorials this week. There are plugins that allow you to just publish a simple interactive map through QGIS without writing any lines of code. So there is one, QGIS 2 Web. Probably there are other examples. So you can still do that. But if you really need to make interactive maps regularly, then you should just get a bit more comfortable with coding and scripting. This is based on personal experience, but I think if you are comfortable with JavaScript, you have the best possibilities, because even if you're working with Python, like Folium is based on JavaScript. It's just we are using the Python interface of it through. It's based on Leaflet, which is JavaScript library. We are using Folium, which allows us to interact with it through Python. So JavaScript is very powerful with that. There's Carto CSS, and there are a few other things. In this course, this week, we are using Plotly and Folium that work nicely with Python. Here I will show you one thing. So this is a data set that many of you are familiar with, especially those of you who have taken the AutoGIS courses. We have worked with this Helsinki travel matrix many times. So it's this travel time calculated for all Helsinki area. It's a data set produced by DGL, Tuuli Toivonen's lab here. So this is something I was working with. It's like very simple. I was just trying things like last year. So we wanted to visual. We have this data set for those of you. How many of you remember this data set, this travel time matrix? Oh, like more than half. So the data set is like many Excel sheets. So if you just download the data, it's just a lot of, it's a CSV or it's a spreadsheet format. So if you're just a planner who is not very comfortable with data analysis, you might be just lost with all the CSV files and not know how to. So we wanted to create some kind of interface for a wider range of users to just browse what we have in the data. So we came up with 3 ways of visualizing this data set. So one is just viewing the matrix. You just click on a point, you can see how far you can reach on foot or on bicycle, or getting travel statistics between 2 points. This is another possible useful way of visualizing the data. And then the comparison, to just compare different travel modes. So what I decided to use was Plotly, the same library that we are going to work with this week in the tutorial. And the reason I used Plotly is that Plotly works very nicely with Flask. Has anyone used Flask in Python before? Yeah, so Flask is, and this is something I have personally needed a few times, so some of you might need it, and then you can revisit this concept later. So Flask allows, if you have a web app with Python, and you want to turn it into if you have an app in Python, you have written a code that does something, all the things you have developed in AutoGIS course or in this course, and then you want to share it with people as a web app, then, of course, many of us have made websites with like WordPress and other, like PHP and other methods. But if you want to include a Python app, then you should have a web framework for Python. And one of the good examples, there are a few of them, like there are a few of them, like Flask is one of the easier one to use. So Flask allows you to create a website purely with Python. So you don't need to write HTML or PHP or anything. You can just make a website. So it's ideal. If you have a GIS app, that works with Python is just, you can turn it into a website. So this website is purely Python. I haven't written any HTML. Well, you need some HTML to move things around or change the font, but you don't really need HTML. So anyway, Plotly works very nicely with Flask. So if you ever need an interactive tool that can be turned into a web app, like this one, I haven't used this in a while, so hopefully it still works. Yeah, so you just click on a certain cell, and and we have like a database here which is like 40 gigabytes, but it works very fast. So it just reads the database, and then you have adjustment. You can choose what travel mode you want, how far you want the person to, how far buffer you want. So it's an interactive tool. Yeah, so this was just an example. So there are a number of ways how you can interactive maps. Just remember what you need it for. If you want to turn it, for example, into a web app, in my case, Plotly seemed to work nicely, but there are probably other solutions. So that's another thing that you may want to take into account when you're choosing the right tool for that. For simple visualization, probably we can just export an HTML, and that's the level we need for this course. You will see it in the tutorial. You just export the HTML, whether through a QGIS plugin or from Python, and then just use iframe or something to embed it into your website. But yeah, that we cover in the tutorial. So methods and tools for mapping. Well, we have a lot of tools. We have talked about many of them during this course, so I try not to repeat them. But depending on your skills, like do you know programming or not, what software you're comfortable with, then you can choose what tools you want to use. Of course, the more you know, the better maps you can produce. So if you are comfortable with many software, if you already also know graphic design, of course you can produce better maps. So if making maps is something you're going to do a lot in your job, then you should improve your skills in a number of things. If you're going to produce like maps that you need to repeat all the time, reproduce all the time for different areas, or if you want to make interactive maps, then as I've said before, learning a bit of programming can help you. Also, you should think about integration. So sometimes, very often in real life, it's not that I just make maps with Python or I just make maps with QGIS. It's often very like integrated process. So in my case, it was easier for me to learn Python because I worked with QGIS and ArcGIS a lot. And you know, with Python you can integrate very nicely with those software. So in GIS world, that's one of the reasons maybe why Python is quite popular. There are other reasons as well. But yeah, integration is another thing to consider. If you're working between different platforms, you should consider how you can integrate your work properly. So what are the tools that we make maps with? Of course, we have the GIS software we are familiar with. Last year, we had some students like more from the art side, and they were really using like different software for making maps, like a big part. Of course, they were doing the data handling and everything in GIS, but doing a very big part of the visualization in softwares that I was not comfortable with, like using Photoshop or other software. So that's perfectly fine. Many people do it, and the maps usually look very nice. There are online platforms for making maps that we already mentioned. There's programming that we also talked about. Yeah, so of course, like this is an example from one of the cartographic books in this course, and this is just an example of the same map. So probably if you just use QGIS or ArcGIS, you will end up with this kind of map. But I'm not saying this is necessarily a good map, but this looks visually more complex. So someone might prefer to have a map that looks a bit more like that. So this is something probably you cannot achieve easily within QGIS. Then if you know some graphic design software, it helps you to do those kinds of visual effects. So if you're really ambitious with your design, then you should learn a bit of that as well. So now moving on to another topic, and that is classification. I already spoiled it, but these maps are based on the same data, but they look very different. So if you know nothing about maps, if you just look at this, you couldn't even guess they're the same data, and they tell you very different things. So students in ESPO, like the proportion of students in the population. If you just look at this, you think that, okay, I suppose like it's very homogeneous in that regard, and there's only one area in the eastern side of, I assume it's the eastern side, there is no north arrow sign, but anyway, in this area, in the right side of the map, there's an area that has very high proportion of students, but otherwise it's very like uniform, which is not necessarily the case. Using the same data, same visualization, only changing the classification, you can get very different pattern. So classification might seem like something that is not cartography necessarily, but it affects your map significantly. So a bit like projection. Projection, you often learn about projection like a course in geology, or so it comes from there, but it's very relevant to cartography. Same with classification. So classification is very important, and you have to be very careful with that. When we were going through your exercises, we saw a few times problems with classification, and we decided to cover it briefly, at least during the lecture. So classification is systematic grouping of data based on one or more attributes to have a clear map that conveys the message better. Because very often, especially when you're working with quantitative values, you have a lot of values. So if just a person is looking at your map and you have, well, sometimes you just go with graduated colors, that's a different kind of map. But if you want to have classes, then if you have like 1,000,000 values or 100 values, it's just unusable. Then you have to classify your data to just generalize and simplify it a bit. And it makes the map more usable. So one mistake that I've seen already a few times in your exercises, in your submissions, and it happens quite often, is the overlap between classes. So very often you have this overlap. So there is no overlap here, but very often people put classes like 6 to 12, 6 to 13, 13 to 20. So it's just, where is 13 exactly? So it's like if you want to be precise with your map, and that's a common mistake you see a lot. So you have to specify. You can put this like mathematical signs to show where it is exactly, or just do it differently. But that's a very common mistake. Avoid overlaps between your classes. Probably you don't have the overlap, but in the legend you make it seem like it has overlap. So try to avoid that mistake. So how do you come up with classification? And again, that's a question that we have faced probably from early days of studying GIS, that you're making a map in QGIS or ArcGIS and you have to visualize it. You don't know what classification to use. And how to do it, like, well, first of all, you should know what kind of options are available to you. And you should have a good understanding of your data. So very often, if classification is really affecting your data a lot, then you should pay attention to it and look at the distribution of your data. So very often we start by creating a histogram of our data. This is something we did in AutoGIS course when we were working with classification, map classifier library. First, we created a histogram of our data to see the distribution, and that might give us a hint what kind of classification might be better for our work. So visual analysis is a key step to take, but also you can look at the statistics. What is the average? What is the median of your data? What is the maximum, minimum? It gives you an understanding of how things are. Another important thing is the number of classes. This is another common mistake many of us make. Well, the mistake is to have too many classes. So there is no magic number, but then again, there are these guidelines from cartographic books. They recommend the number around 7 plus minus 2. So like ideally, you would have around 5 to 7 classes, but maximum 9. So this is a number, if someone looks at your map and the legend, they can distinguish these classes fairly easily. But if you have like 20 different colors on your map, 20 different classes on your map, it just becomes complicated. So if you have, unless you really have a strong methodological reason why you might want to have many classes, from a cartographic point of view, try to limit your number of classes to around this number. Then about classification methods, there are different ways. So when it comes to classification, but there are different ways. Sometimes there are some standards, there are some common habits, like certain ways of classifying data. For instance, if you use data from Statistics Finland, they classify age ranges to certain classes. I don't remember exactly what the ranges are, but they define it in certain ranges. Then if you don't know how to classify the age in your map, if that's something you're visualizing, just use a Statistics Finland if it suits you, because it is common and many people here use data from a Statistics Finland, then you don't have to think about it if that works for you. But if you have some strong reason why you want to classify it differently, then there are different methods, quantitative methods for coming up with classifications. So you can go with equal intervals, you can go with different kinds of quantiles, and then we have the maximum break, natural break algorithms. So there's a bit of more detail about these methods, but I guess most of us are familiar with this. So equal interval is this, as you can guess from the name, you just put equal intervals in your data. Sometimes it works, sometimes it doesn't. If your data is very skewed to a certain direction, then if you have equal intervals, you might end up with classes that are empty. That's another mistake you should avoid. If you have a class, you have to have value for it. So if there's an empty class, it's not good classification. That's very often you go with quantiles to make sure you get a fair amount of values in each of your classes. And then you have a standard deviation classification based on the standard deviation of your data. And of course, what we very often use, it's become a kind of a standard for GIS, is the natural breaks, or the Jenks method. So there's a visualization of how these different classifications work. As you can see, same data, you can just put the lines in different places and have different classifications. Again, another example showing how important classification can be. This is a map from showing country population in the United States and just using different classifications. So the maps look very different. So you can see that same data, same area, just different classification, you end up with very different maps. So that's why it's very relevant to think about it. Yeah.
Sorry, maybe you're going to mention this later, but what I'm always thinking when I'm making a map like this is, what's exactly would be the advantage of making a set of classes instead of just making like a color bar? I usually feel like having a color bar is like much nicer looking, but also like can represent more. I can represent exactly what each thing is instead of making it look.
Yeah, yeah. But one of the things is that you can, in color bars, it's hard to show the exact value. It's like you can kind of guess the range. With this, you have like proper glasses, so you can. It's like when it comes to analysis, this is a bit more useful. For purely visual reasons, a color bar would look nice, a graduated color. But if this is something that you're going to analyze, like someone is going to do visual analysis, then this is more scientifically accurate. And very often with your data, you publish also, with your map, you also publish the data. Then this is something that people are interested in. They have the classes. But with that, you don't get it. And then it's with those, it's a bit of a black box, how the visualization. Here you have control, you know your classes, but when you're using this scale bar, very often the software or Python is just applying some function to, in Python we have the CMap. It just maps the values across the color range. So it's a bit of a black box. Here you have a bit of control, like how it will look like. So it really depends on what you want to do. But sometimes this can be more scientifically accurate. Yeah, so I would suggest that we come back to this after Tuuli's talk. So now we take a break, and after the break we will continue talking a bit about this, and then talking about the final project of the course, and then hopefully there will be some time we will have a discussion together. Yeah, so let's take a 10-minute break and be back here for Tuuli's talk.
Yeah, so I can just start, but maybe I'll say anyways if there's a recording. So my name is Tuuli Toivon, and I'm a professor of geoinformatics here at the Department of Geosciences and Geography. I'm super happy to be here with you on the cartography course for all the possible reasons, but one of them being that I was teaching cartography course myself between the years 2000 and 2012 yearly, even if I did my PhD in Turku at the time and so on. So this is really nice. I think that now we have a new version of the cartography course made by Kamiar. And he asked me to be presenting one of like some map I could be choosing. And of course, there's many maps in publications and elsewhere that I could have been choosing from, but I chose this one, which is 10 years old already, but for the reason that it carries several different sort of thinkings behind how to make cartographic visualization efficient, and then some things that were not planned as well that I wanted to share with you on this one. And it's a paper that you have also in paper with you there. So published in magazine Nature, which is sort of important in the sense that it's the most appreciated scientific journal in the world, alongside with Science, and usually something that, well, at least in my case, but in most people's cases, that when you publish something in Nature, and if you're an academic track, then it sort of changes your career from there on, because it's so appreciated. And therefore, like when we submitted the paper, it's by broad group of people. You can see maybe familiar faces. Enrico is a professor nowadays here at the department as well. And Fede and myself were the sort of first authors, so sharing the responsibility of acting as the first authors, carrying out the analysis, collecting the data, and then, of course, writing the paper and making the visualizations alongside with the whole group of people. And Atte Moilanen, as it's often the case, by the way, if you don't know, so the last author is the one who's the most senior and has been sort of getting the funding and supervising the work. So we were working at the time in Atte Moilanen's research group and doing spatial conservation prioritization. And this is an example of sort of global spatial conservation prioritization effort that was made, and it was super special at the moment when we did it. And maybe just to give you a brief background why that was, well, maybe still to point out that I'll be showing or discussing 2 maps from there that I've made and had to be thinking about the visualizations there and some of the visualization choices as well. So what I would like to be covering through that example, which you have now also on paper with you, and there's a reason why you have it on paper. So one of the things was the color selection. So how to communicate most efficiently the main findings of the paper, then how to make sort of create harmony between the different visualizations that are there, so that it would be assisting the reader to be getting the essence, like the message which was the most important, out from the visualizations, and then the things that had to do or have to do always with color selection and other selections as well, be it line width or be it the text and so on, that what's the difference when making a map for screen and when making it for paper. And there is a difference, and you can tell the difference already by looking at the paper printed versions that you have at hand. Then there were some other considerations that I thought that might be interesting related to the projections, and choosing of those, and then something on the background, like in the data itself that we chose, and how we wanted to be then sharing the results also afterwards. And now I'm checking the time. I can speak 2 hours of this, but how much I have? 20 minutes still. Okay. So just to give you a brief background why the analysis was sort of interesting, and therefore what the maps try to be communicating as well, was that this was a time when we started to be making the analysis, when Global Convention on Biological Diversity, so CBD, had these kind of targets for the year 2020. So now we are past that, and none of the targets have been met, by the way, but there was a target called Aichi target that then pointed out that at least 17% of terrestrial areas should be under protection. At the time, when we started to do the analysis, the percentage was 11. So in a way, the whole idea of the paper was to be seeing that if this terrestrial protection would be sort of expanded from 11% to 17%, so where should it be placed, potentially with certain data sets that we have at hand to be analyzing the priorities for the protection. And then if the decisions of the protection are made on a global scale, like utopia, because there is no global president that could be deciding that this is where you protect, and it wouldn't be also fair for different areas in the world to be doing it that way. But still, we wanted to analyze that if you could be placing the protected areas freely in the world or within the national boundaries. So what's the difference in the conservation outcome? Because national scale is where the decisions actually are being made. Then there was another thing that we wanted to analyze, which was that as we know and knew that land use will be changing over the years, and habitat destruction is one of the key threats for most species that we analyzed here. So what does the land use transformation, land use change most likely will do to the possibilities of protection and therefore conservation outcomes? We didn't consider climate change, we didn't consider many of the other things, but this was like testing these two major things, so decision-making scale and land use change, and then using terrestrial vertebrates, so 24,000 species and their species distributions. We attempted to be making a global prioritization of where we should be making the expansion from 11 to 17% globally, nationally, and considering the land use. So only terrestrial vertebrates are taking into account, and that means mammals, birds, reptiles, amphibians, basically. So no plants, no insects taking into this thing. Okay, there I say 25,000, so it's 24,000 something species which have been red listed, so appear in the red list book. They all are not sort of in high need of conservation, but we took them all in, and out of all of these, IUCN, so International Union for Conservation of Nature, has been creating these range maps that where do those species roughly occur in the world, and we used those maps, which are vector maps. We rasterized them into the resolution of 1 kilometer globally, and then 1 kilometer at the equator. As you know, the scale is always changing depending on the latitude, so 1 kilometer at the equator, and then we carried out the prioritization, which was, like, at the time, computationally also an exciting thing to do. We used also ecoregions, and then this land use for that time present, and then a future prediction for 2040 for the land use, which was made by Dutch colleagues. So Peter Verburg and others had been publishing a map on projection of land use change, and we used that as a factor to be then limiting these distributions, thinking that what species are impacted by land use change, we were then sort of changing their current distribution by cutting out those areas that wouldn't be available for them as habitats anymore if that land use projection took place. That was the idea. Then we used protected area network of the currently protected areas, and then country borders. And while these came from IUCN, that came from WWF, that came from Peter Verburg, a closed data set. This was from Protected Planet, WDPA global data set maintained in Cambridge, and this was Global Administrative Units database. And this is important why I list these, like there's a point to know that what were the sources of the data. Then we put them into zonation prioritization software that has been developed at the University of Helsinki by Atte and the team, and they are still continuing. Atte is now out of academia, but it's still being used and also taught at our university. Mainly used in Luomus at the moment, but also in Enrico's conservation prioritization course, zonation is being used, and we've created all sorts of materials for that over the years. And what zonation provides as an output, many things, but two important things in this context, what we wanted to communicate. One is the map, like where are the priorities to expand this protection. So if we take the currently protected areas as the starting point, don't do anything for them, but then start to be seeing that where would be the next places to protect on that 1 kilometer square. So then it sort of distributes all the land in the world takes that as 100% and then starts to be allocating in a way in percentage order these pixels, that this would be the next 18, like, next 12%, 13%, and so on. So to sort of divide the landscape, which is in this case the whole world, into priorities that which from the 11% of the current protection would be the most important. And this graph sort of shows from the current 11% that with red, those areas we wanted to be visualizing with red, those areas which would be then falling into the area between 11 and 17%, and thereafter, so that we reach the full coverage of the world. These areas between, for example, 90 and 100 being the least important for conservation of those species that we took as input to the analysis. And indeed, then we wanted to be visualizing the results with maps and graphs. Both of them are needed in this case. Like, this map alone doesn't do much. It shows where the priorities would be. We chose to be choosing colors, and this was extensively tested, that what kind of colors would be working. But as you know, red comes to your face, isn't it? Like, red is a color that approaches, while blue is a color that sort of draws back from you. And because Antarctica, for example, is big in this projection, which is Robinson projection, so we put blue also for other intuitive reasons. Blue here to the lowest category. And you see how the blues are distributed in the world, and reds are maybe more scattered here and there, particularly in the national version, which looks very different. Like, when you have to be allocating the percentages, like this scale, within the country borders, so then the result is very different in a way. And what is interesting, of course, are the reds, so how different they are in this global model and then in the nationally limited model. But as in both cases, the reds, which are the most important, are scattered. Red was a good color choice because it's visible. Any other color would not be sort of coming to your face similarly. And as this was the whole point of the story, so therefore choosing red. And then we wanted to provide quite detailed information. Of course, it's difficult to say that what's that color exactly. Is it this and this? Or is it that or that? Well, you can see it as the blobs are relatively large. But should they be smaller, more scattered, it would be difficult to pick the color. So these were some of the considerations that we had. And there's a rule in cartography, which you might have encountered, also that there also always should be some red on the map. So that's by a Swedish cartographer that I have learned back in the days. So to make a beautiful map, always include a bit of red, but it's a bit is the key. In this we have quite a lot of it, because it is indeed the 6% of global coverage. As this is Robinson projection, Robinson projection is a global or projection that fits well global presentations, as you might know, but it distorts everything. So as you know that like sphere can't be presented on a paper without distorting something, and there are different things that one can distort. Robinson distorts everything, but it's sort of good average of many things and works particularly well in these kind of visualizations. But areas that the colors cover now are not real, and therefore we then calculated the current protected area, like made a graph on the side, showing that how much there is on this latitude now protected and how much this model suggests us to be protecting if we would be following this. And the point of this is to show that a lot comes to the equator, where the biodiversity is rich, meaning, of course, that if this would be followed, that would be putting like enormous pressure to these countries that are situated in the equator, and let, for example, the northern countries free of doing anything, therefore requiring a compensation financially. But of course, this is utopia because decisions are not made this way. But the graph sort of aims to be bringing the area into play. on the latitudinal scale, and that was something that we were quite happy of, sort of finding or thinking that this would be useful to do. And also still thinking about Greenland, for example, which is in current Web Mercator projections, as you know, it's huge always. It's almost like the size of Africa when you have a Web Mercator projection, which again, because of its ease of creation, it's being used quite a lot, which is really, really problematic, of course. Greenland is smaller than Sudan, for real. And in here, as it is a quite good version of the global map, it still appears quite big. And if you look at the protection levels, for example, in the graph, so even if that protected area is the biggest protected area in the world, the Greenland protected area, still it's not as big as some of the more southern, or of the same size as the more southern protected areas. Of course, there's less land in there, so in that sense, like in percentages, it's quite large body of land which has been protected up north. Yep. Then maybe, yes?
Just one thing that I thought was a bit surprising. Why is Antarctica such low priority? Because we are always, I don't know, I feel like I'm always seeing news about all these ecological problems in Antarctica and all the species there are having problems. Why did it come up as such low priority in this analysis?
Because it's terrestrial vertebrates that are the input for it. So only terrestrial vertebrates. So basically there would be, of course, bird species, there would be seals, and so on. So, but still, there's so much more in Amazonia, for example, like millionfold amount of species. So not terrestrial vertebrates, though, but species altogether. If thinking about insects and everything, so in a way, this gives a good view, I think, overall, if thinking from species perspective only. But this is not the only perspective that one can have for real. So if we would be going with species and, for example, only terrestrial vertebrates, so selkärankainen in Finnish is vertebrate. So of course we wouldn't protect anything in Finland, for example, and that's not how we want to do things for real. But that's the reason, like the analytical approach here. And maybe that's one thing which is important here, that always when you present a map like this, it becomes truth in a way, like in many people's eyes, that this is what the researchers found, that these are the areas that need to be protected. And this is what we found that could be protected if considering the 24,000 terrestrial vertebrates. Plants are not there, insects are not there, landscapes are not there. So in that sense, like, it's not the truth. And that's super difficult to then communicate to those who have the map in front of them and want to be taking that as something very, very sort of serious. On this scale, it's obvious that decisions can't be made with this. But we've made similar analysis, for example, for Regional Council of Uusimaa, for Helsinki, and so on. And there it becomes like really a land use planning question. And still, one should be remembering that had we been choosing something else, some other parameters during the analysis or input some other data, the results would be very different. And in those cases, we then try to be developing and have tried to be developing methods to be communicating the selections as well. So whenever putting a map in, then also showing that what were the inputs, always on the side of the map, so that they can't be separated, so that the viewer can't be escaping the fact that in this map there's different input data, for example, than in this map. And therefore they are different. And then one has to be doing their own interpretation to really think that what then is the decision that we want to be making. Maybe one thing I'm already almost out of time.
Yeah.
4 minutes. So maybe one thing that I want to be pointing out is if you look at the colors on the paper. So we threw these in. I have been teaching cartography. I know about color systems. This was made in RGB. I did test it in SMYK, so cyan, magenta, yellow and key system, which is always used in printing, but still how lame it became. Like the paper influences, the printing machine influences, it was such a disappointment to be seeing those turned through the sort of printing process into this. because we wanted to have vivid colors like this. So just color, like printing is very different from screen. And if you really want to do something serious, so always print for real before you decide on the color palette. In this case, that wasn't possible. Maybe one thing on harmony, which is that indeed, when we presented then, so I said that there's another important part in zonation outputs, which are curves. So where the map shows locations, that there is where you could be protecting things. It always still distributes the world or the whole area that you're analyzing into these 100% in a way, and then forces an order for the pixel. And the curves that tell that how well these different percentages then are able to protect are super important to understand the real outcome. And these now present species range protected on average with this model that we presented on the map. And then we try to be thinking that how do we make these meaningful and readable, these lines? First of all, choosing super bright colors, but then also coloring the background with the same background as the map. And that wasn't the usual case to do in zonation analysis earlier. Now everyone does it because that's sort of easier then to interpret that, okay, what was red on the map is here as well, so that we can see that from the current level of protecting the terrestrial vertebrates, roughly 20% of their ranges. This expansion through the prioritized setting in the global scale could be improving protection on average to roughly 57%. So in a way like that, that is very important to know in order to be knowing that what's the real conservation outcome. Just the map is not alone meaningful, and that's why matching these was super important. Yep. Then still another quick point on the projections. I talked about Robinson and it not being very good well, it is very good for global presentations, but then when we wanted to show that where are the global priorities, so following the global model and 17% from there, then following the national model, 17% from there, and where they would be overlapping. So which would be the places where with national decision-making system, you could be protecting also those places that are globally important or deemed important. So again, red for the most important and the smallest, and then just two colors that wouldn't be competing in importance. Very basic coloring in here, but maybe more exciting in this one, which I'm happy about, is that how to make with these detailed scattered points a global presentation. So then, as you see, it's a panel. All the Cs have been, in a way, removed, and all the projections are chosen for those like UTMs or Universal Transverse Mercator, which is correct here in the middle, and then it starts to be distorting a bit in the edges. But still, the best projection for each continent was chosen. So all of these maps are in different projections to be respecting the regions as they are, or present them as well as they are, and then taking out the C in order to be really saving space in here. Well, the last, do I still have a minute? Yeah, so the last thing was that we went to Sydney, and there was once a 10 years conference, so super big event, IUCN World Parks Congress, and we got the paper out, got the decision that we are able to get it out in Nature, 4 days before we had a presentation on this. Super exciting that, yay, we are getting a Nature paper out, and this is the exact topic that they are speaking about, thousands of people from all over the world. And then we were there in our Airbnb and got the message that it can't be published because you have been using data which doesn't allow you to be publishing it. You have been using proprietary data. And we were thinking WWF open dataset, IUCN open dataset, from Fairburg we had the sort of permission. All of these were open datasets available online. We had downloaded them. But their license said that not for commercial purposes. And as you might know, scientific publishing is the biggest robbery in the world. So like the most commercial activity that one can think of. Even if we think that we are not part of it, the publishing company is very, very commercial. And Nature said that we can't be printing this because you have been using data which you don't have right to use for commercial purposes. Luckily, it was so that as it was a Nature paper, and I'm now uplifting it because it has a meaning in this story as well. So then we wrote to WWF service address, IUCN service address, all like huge 1,000 people organizations, that paper coming out in Nature, permission needed. And we got responses in like 4 hours from all of these places. With the written permission, you can go forward. And then the printing started, and then we could be presenting it as it is in the conference. Yep. And maybe with that, I could be then closing and hope that you got something out from colors, projections, and the data use. Yep. Thank you. Thanks for asking, because that was something that I thought that I don't have time now to say. So we developed, because it's so detailed map, so developed by CSC, or with CSC. So CSC is the computer scientific computing center for in Finland. So we developed with them a service, map service, that we designed and they executed or created on their servers, where you could be both sort of zooming into the map like normal map service and then a download service. But what happened was that they ran out of the project that was responsible of sort of maintaining these map services, and it's not available anymore. So the data is on our, like on DGL, Digital Geography Lab's web pages. There's a point on this, and then it said in the article that you can be getting the data. They were sort of ahead thinking in Nature, and they said that they won't be putting any links there to our data service. So now it only says that you can be asking it from the authors, which is not open data practice that we would like to have. So now it's so that you can ask it from me. FEDE is out in the world elsewhere, and I'm sending it like 3 times a year to people who ask it at different resolutions. And should be actually thinking that how to put it fully online. We haven't now, after being disappointed of CSC's closure, so we haven't made anything to really sort of re-put it somewhere in an archive. Yeah.
You have chosen on that map with the continents the colors green, red, and blue. But I'm wondering if there was a specific reason for not to take account of blue, green, white.
Yeah, I did think of that quite a bit, but then as they are so small, like if you would like to do a colorblind friendly version, so then one would need to be having these shades of like shades of yellow, shades of brown, shades of blue, and out of those it's quite difficult to find sort of solution that would be really such that it would be separating the small pixels, and then like on the expense of colorblind people, we chose the most bright ones, which were these. Yeah, a sort of this intentional choice, but of course with sort of a lot of consideration. Yeah, okay.
Yeah,
Thanks.
Thank you, Tuuli. This linked very nicely to many things that we had covered today and previous weeks, so this was really good. Thank you.
Thanks. And enjoy the rest of the course.
Yeah. Okay, see you. We can bring them for you later. Yeah. Okay, this was very nice. Already, like from a more practical point of view, Tuuli walked you through many things that we have been talking about: choice of colors, projection, and printing versus digital presentation of maps. So this was great. But now let's continue with what we had left from our own lecture, which is not so much. Then we will talk about the final project, and then we will have discussion. So we have been doing this course now already for 3-4 weeks, and we have been making maps for a longer time, I'm sure. So far, how has AI helped you in making maps? So to what extent? And there's no judging here. We all use AI to different extent. So how much have you used it and what way? This course, your own work, anywhere related to maps. Yeah.
Well, at least in Python, it's made like much faster. Commands the specific functions for the mapping. There's so many. Before you have to go through the documentation, and you just do it right away. So that's like a lot.
Yeah, that's a very good use of it, because, like, you know, we have worked with Matplotlib and many libraries. There are many ways you can customize your map. There are so many parameters. It's just so hard to. You can't remember everything, so it's helpful. What else? In what ways have you used AI for map making?
Choosing some colors.
Yeah, that's also very good use. Also, I tested it a bit. It works quite well also with like color palette and things we talked in the second week. So if you're not sure what color is complementing what colors, then the AI can help you a bit. Of course, you should always double check. Yeah, anything else?
So with coding in general, but also maps as well. Often I'll have like a general idea of what I want to do, but I don't have much time. For example, we had a conference a couple weeks ago, and I got some data that I wanted to show like 2 days before my presentation. So like, I can, after I get some code, I can tweak it myself. But if my conversion has to be quick, I can just say, hey, I need to do this, and just this is the thing. And then I can go back and change the details, but it's much faster than doing it all from scratch.
Yeah. Okay, that's also a very good use. Yeah, so you can see that the AI is getting bigger and bigger all the time, and you can see it has already emerged in like individual pieces in our work, but I can see a direction that all these things come together, and then we will have a more integrated AI-based system for cartography. Now there are these individual pieces. You use it for color, you use it for, I don't know, helping with code or small visual details. So it's like, I've been like we're doing a research, like what is happening in the world of cartography in relation to AI, and I can see there are all these pieces emerging, but it's still at its infancy. So it's like interesting to follow what will happen in coming years. Yeah, so this is just based on my personal experience and how I've seen people using AI for cartography, some of which already came up in your opinions. So yeah, helping with syntax and code writing, particularly with visualization, it's just saves you a lot of time. You can use LLMs. We are familiar with many of them, ChatGPT, Copilot, and so on. And recently we have been seeing this, like for example, MapGPT is new. There's I guess also a GeoGPT. So these are LLMs. Most of them are based on the same base model as ChatGPT, but they are trained more with geospatial information. So they are a bit more educated. Like those generic models know a bit of many things, everything, but these are trained more for geospatial data and knowledge and everything. So if you ask it like geospatial related questions, I haven't worked with them so much myself, but they're supposed to give you better answer. So yeah, because one problem with use of AI in very like specific, like GIS is very specific, it's very narrow. So if you think they have trained the models, ChatGPT, on a lot of data, very like crazy large amount of data. So GIS is a very tiny amount of things. So if you think about it, if you ask a very specific question about GIS, because it knows all those other things, so the knowledge is a bit biased. It's like, so you get a bit like mixed things. That's the idea behind these LLMs that are trained more for geospatial sciences. So it's a bit like knowledge is balanced. Yeah, so it can help us in lowering the manual work, like you said, in many different ways, helping with color choices, as it came up in your comments. When it comes to image generations, and actually I was just having a talk with Tuuli before she started presenting her work that she asked for, was it Tuuli that said it? That she tried to get a route from, she asked ChatGPT to give a route from Helsinki to Stuttgart or somewhere in Germany, and like it gave Tuuli a map, but the name of the places were wrong, like Turku appeared somewhere in Sweden. Like, so it's like there is something, so it has some understanding of map, but there is just so much inaccuracy. So they're not there yet for producing maps. That I got, I guess, from ChatGPT. Just ask for a nice world map, and it gives you something, so there is some understanding there, but there are like 10 north arrows there. So.
One thing I was thinking about Panto was there at SLPS conference in Malta. The paper that won best paper was a paper where basically was a postdoc survival. What he did was he asked ChatGPT to plan a journey in the London Underground, and then he would actually make the map, like what would the map of the London subway be if you could do what ChatGPT told you to do. And it did exactly that. Like, it invented some stations, it put some before others, like as they weren't there, and like the map that ChatGPT like drew, because it didn't draw a map, it just told you what you should do, right? But then he would take what ChatGPT said and actually draw the map, and it looked like completely different from the real map.
Yeah.
It was super interesting.
Yeah. Yeah. Very, very good example. Yeah, but so we are getting there. We can see that like it's happening, but it's not quite there yet. So you cannot rely on AI yet for map generation. There are some efforts. I've found like one, I've been familiar with this project for a while, iknow.world, and it has been advanced. I haven't checked it lately, but the idea is brilliant. It's like you want a map, but it's a bit like ChatGPT, for instance, or other AI LLMs, that you make a prompt that I want a map of green areas in Finland. So what it does, the LLM fetches all over like the open data it can find from the web and makes a map of the place. So that's the idea behind iknow.world. So it already gets the data for you, because the capability is there. Like ChatGPT can write you the code to get the data from WFS from somewhere, then processes the data, and then it can also visualize. You can say map green areas in Finland in color green for me. So it produces, the output is not super amazing, so I wouldn't include the map anywhere, but it's a nice effort and it's a nice direction. So there are such efforts as well. iknow.world is one example, but I believe there is more out there. So what I would say, and you said current situation is that AI is already involved in many steps of our mapping, but it's not like, we cannot fully rely on it yet. So I did a bit of search. I found some nice projects that are using AI, nice projects, nice places where AI has been used in mapping related activities. I haven't personally tried most of them, so it's just for you to explore. If you're curious to check some of these out, then you can explore a bit more. So AI has been used to enhance aesthetics. So like you said, it has like it came up in your comments, it can help you make things a bit nicer with colors, layout, and some small details. So there are, it is like used like that. A couple of examples of that, like DALL-E, which is like by ChatGPT, and Midjourney have been used for these purposes. And AI-assisted map generalization, like it's more like on the GIS side than cartography, but like, for instance, in ArcGIS, we have this GeoAI toolbox where it can help you with like data classification, data generalization, a number of things. So it's not, it contributes to your cartography process. So they are very present in classification, generalization. A number of these things have been automated using AI already, and it can help you reduce the workload, especially with larger scale mapping. Yeah, it has been also like, AI is very strongly present in also mapping for navigation. For example, this used to be it's a commercial project, but some part of the code has been like made public, like NVIDIA and DeepMap. So they mainly make maps for navigation in like electric cars, like more modern cars. And they use AI for improving their maps, the visuals, and also the data in the map, and that's also a nice effort using AI for mapping. But yeah, there are so many pieces emerging already, but we're not fully there yet. So this is some slide that I've shown you a couple of times, and this is I'm using this slide to wrap up the lecture part of the course. So what we tried to learn in this course was the elements, the things that make a nice map, so things that you should follow. We have talked about projection, colors, harmony, like some technical details, theoretical details about maps, and then we have learned some technical details, and we are still learning in tutorials and the final project, and we see how we can implement these to create nice looking maps. And that is something that leads us to the final project of this course, and it's based on the same idea. We have covered the theories, and now we are continuing with the final project where we get to implement these ideas. So I will cover details of what it actually includes, but the format is, well, we asked the students last year, and this year we are asking you to publish it as a weblog. So a bit similar to what I showed you in the first part of lecture today. So it would be a story. We would like to see you writing a narrative about the data, exploring a certain dimension of a data set that you find interesting, and explore it in different ways, with text, with visuals, maps, different kinds of charts, images. So explore the data visually in different ways. That's the purpose. We encourage you to use Weblog, and in the course's website we have made a few recommendations how you can do it. Those of you who are studying in Helsinki, and probably similar in other universities, you get this personal weblog that you can publish for free, like in the University of Helsinki. So you can just use that as space to make it. Some of you might have that weblog in use for other things. I talked to IT earlier, and if you just send them an email, like, they can give you a second one if you want it. Many of you are familiar with GitHub, and you know that in GitHub there's GitHub pages, so you can host a website for free, and it's quite easy using GitHub, so you can host it as well there. But there have been a few students last year who didn't want to do it. It was just too difficult for them, or whatever reason. They also they talked to us and they submitted a PDF. That's also okay. Weblog works nicely because of all the things we have learned, like interactive maps and everything. You can just bring them in one place. But if that's a problem for you for whatever reason, you can also submit a PDF and then send your interactive maps, for example, separately as an HTML file. On the website, we have also explained how you can publish your interactive maps, like on a website. So there are some technical details that you can go through. I will skip those for now. Yeah, so that's the idea. And then once you're done, what you will submit, if you have decided to go the weblog way, what you submit is just a link to your weblog in Moodle for the final assignment. So that's all we need. And yeah, so what you share there is up to you. So if you don't have to put your name or anything, because we know who you are from Moodle. So you do not need to share any personal information. So it's like, we don't ask you to do that. So it's up to you what you want to share there. And the deadline for the final assignment is 16th of June. Of course, most of us go on holiday after that. So if you want to get your grade in time, then submit latest by 16th. Then we try to get your grades in before Johannes already. So, and it's an individual test, so there's no group work for this. So these are the steps you should take. Again, there are more details on the course's website. Choose a topic and data. We have a few suggestions for you, but you can choose whatever data, whatever scale you want. It can be world scale data or something local from Finland or a city in Finland. So it's up to you, whatever interests you and gives you the possibility to explore different ways of visualization. And try to be organized and practice some of the things, because now it's a good chance you have a couple of weeks to work on this, and you can practice many of the things that we have been talking about, for example, the iterative process and making the sketches first before finalizing your work. So try to do that, and try to consider your portfolio as a cartographic journey where you can visually explore a topic that interests you. So that's why I'm emphasizing try to pick a topic that interests you. Yeah, so this is a course in cartography, so of course we evaluate your work as a lot based on the visuals, so put effort. So it's not about GIS analysis. You might do a great GIS analysis there, but that's not the main point. The main point is how correct and nice looking your visualizations are at the end and the overall presentation of the portfolio. And try to use a wide range of visualizations. So if it's not enough, we just have a data, go to QGIS, export a map. That is very basic. So we have learned many things. We have practiced many things. Try to include them. And the structure of your portfolio, and by structure, I don't mean you have to have these sections. It's just like the components that we expect to see in your work. We want a cartographic reflection of your work. So something that we have done in exercises, but a bit different. In the first week, we hadn't learned so much about cartography in this course yet. We had probably learned in other places. So we want to revisit the map from the first week. So include the map you had made in the first exercise. Just reflect on it. Now, since then, you have seen more examples. You have practiced a bit more. So hopefully you know a bit more about cartography. So just criticize your work from first week and see what things you have done right. And of course, you have gotten feedback from the course assistant, so we can also use those feedback. So reflect on your work and see how you would do it differently now after 4 weeks of learning more things about cartography. Then description of data. This doesn't have to be long, but of course, tell us where the data is coming from, and so we know what to expect. And then geospatial narrative. This is something we have been trying to highlight in this course, so try to take that narrative approach to presentation of your work. And there's some conclusions. What we would like to see you wrapping up your work and also a bit reflect on what you see from the visualization. So if you have made a nice visualization of a certain data set, what does it help you discover? So a bit reflect on findings from the process. And we would kindly ask you to provide us feedback. This is the second year we are doing this course, so there's still room for a lot of improvement, I'm sure. So the feedback opens on 2nd of June, and any suggestions are welcome. Yeah, so these are references for some of the things I showed you today. And we have the reading material. How many of you did have time to read the paper? Yeah, so a few of you, more than our weekly average. Yeah, so do you have any comments, questions about what we talked about today or the final portfolio? Well, yeah, we can do that. We can share a few links from last year, those that have not included their names. So if they have their names, it might be tricky, but we try to provide a few from last year so you can get an idea. But I will put it on Discord, so yeah, good point. Yeah.
What about if I would like to make like a kind of a story map like ArcGIS there, like that, and what kind of platform would you recommend for that?
Well, for a story map like that, I would use Python. I would use Python. I would go with something like Flask that I said. It has it's quite easy, and then you can make this single page where you can just navigate to different places in the page. So yeah, I would use that. Do you know any way in like QGIS or anywhere to make a story map?
I'm not aware of any QGIS way, so I mean, you gotta test ArcGIS a bit also just instead. I mean, we have access to the ArcGIS lab, so that's what we do.
Yeah.
I tried to look at it at one point. To my knowledge, the QGIS one is quite more with these story maps. Yeah. I found like Mapbox, example of Mapbox.
Yeah, yeah. Yeah, Mapbox. Yeah, Mapbox works nicely with Python, so a combination of them can be a thing. Yeah, so if you're ambitious, you can do a great work. There are many good examples out there you can get ideas from, but it can be even simpler if that's too much for you and the time is short. So, okay, so now we want to head to our discussion. We are a bit short on time, so we only have 15 minutes, but let's make most out of it. So in the paper that you were supposed to read, but the title of the paper was Smart Cartography, Representing Complex Geographical Reality of 21st Century. So as you can guess from the title, even if you have not read the paper, it was a bit like reflecting what things have changed in geography in our world, and as cartographers, how would it affect our job. So that's the main idea of the paper. So we don't have so much time, so let's, wherever you're sitting, try to team up with your neighbors and let's talk about these things for like 7 minutes, and then we come back to the class and